right, and fractional distillation in organic chemistry. That is because these are also natural products. And then when we talk about inorganic, we're talking about the most of the things that we can synthesize in the laboratory. We can prepare them, they are not. So that is why everything, even things that are gotten from by artificial means, have some sort of natural trace. Chemistry has organic explanation for many things like the energy we use, the um, the drug we take, plant, the every of this thing has. Please excuse me. Okay. Now these are we have the nature of carbon, the characteristics and features of organic class. You should go and bring your questions so that it will not be a class of repeating things that you already know, but it should be a class where you get to know better those things you don't know yet. Okay. So, but before we get to that stage where you would ask questions, let us do a what I might call a review, because you already know these things. So it's more like reminding you of what you already know. Now in organic chemistry, we say we are dealing with carbons, right? So I don't really have to bore you with some of the areas like petro petroleum, petrochemicals, how petroleums are separated into different fractions. Those are things that you can read and understand on your own. So we'll go to the more handy aspects of this topic. Okay, when that is why we'll be dealing with things like homologous series and the rest. So when we talk about homologous series, it's more like talking about a family from the same group. Okay, so for example, a right, it's a family of organic compounds which follows a regular structural pattern on which each successive member differ by a CH2 group. So homologous series is simply telling you that there are different families. It's more like telling you like that we have human species, we have mice, where we see rats. We also see things that look like mice, like rabbits and things like that, those creatures. Then we also have a family of, let's say, cats, where we see tigers, um, little kitty cats, where we see these other animals of cat, animals that are like are from that family of cat. Now I'm relating it to biology. That is how also here every member of a every there are different, that's also here there are different family, okay, families, and then we have members of that family. So that's what homologous series is all about. Okay, please, I want you to confirm if you can hear me because it's raining heavily here, so I want to be sure that um my mic is giving you fair sound. Okay, so that is how it is. Now the things to see in different homologous series is more like a family surname. So for example, in Melody family, there are 10 of them, and our surname is Alkane. That would mean that every member of that family will be having the Ain surname. That is why the homologous series of Alkane, for example, is going to be meth, ane, ethane, propane, butane, and so on. I know these are things that you people already know. Okay, now the meth there signifies that we're having one carbon. It means one carbon. Et there means two carbon. Prop means three carbon. But means four carbon. Okay, and so on. That's as we have in polygons when we do mathematics. Okay, we have nonagon, we have hexagon, heptagon, like that. It's the same thing here. Okay, but pentagon and so on. But then the end of the name tells you the surname, also tells you the what member, what family that homologous series member is coming from. So the N here will now tell you, oh, it's an alkane, and it also tells you the functional group. Okay, it tells you the functional group that is present there. So when we see propane, for example, we know that the functional group there is a single bond, because bond is also a functional group. Okay, it mustn't always be OH or one writing or the other. Now, having said that, that is for alkane. Now, that is for homologous series. What's the functional group? Functional group is group of hydrocarbons or group of organic elements. This is not a standard definition. That have where every member of the series have the same general formula, and thus they will have the same chemical properties. Okay, it's just like members of the same group in the periodic table. So every member of the same homologous series will follow the same general formula. Now, alkane again, for example, has the general formula CnH2n plus 2. Alkene, we have the formula CnH2n H2n. Alkyne has CnH2n minus 2. Okay, and then when we talk about alcohols, we see CnH2n plus 1, then the functional group OH, and the rest of them like that. So every member has the general formula. The N there is the number of carbon atom. Now this general formula can be kind of hard to follow when we talk about more complex or more advanced functional group like carboxylic acids, like ether, esters, and those ones. So, but these ones are easy to follow because it's the same rule for everybody, and these are the simplest homologous series we have: alkane, alkene, and alkyne. Okay, So they also have the reactions they follow. They also have their method of preparation. These are things you should know for your exams. All right. So, and in the definition here, we say the members of the same group differ by a CH2 group. What does that mean? It means that if we are following this formula for alkane, we are going to draw the molecular formula of alkane to be C. We said N is number of carbon atom, and I said meth means 1. So this is C1. We are replacing N with 1. H2 times 1 plus 2. This will now be C1 H2 plus 2. C1 H4. We don't have to be writing the 1, okay? So it's CH4 for methane. Now, let us write for ethane. Ethane is C2 H2 2 plus 2. Okay, so this will now be C2 H4 plus 2, which is C2 H6. C2 H6. Now, let us write for propane. I'm heading somewhere. For propane is C3 H23 plus 2, which is C3 H6 plus 2, which is 8. C3H8. If we notice the difference between this and this, okay, is a CH2 group. You know what difference is? This minus this. So for you to be able to get ethane from methane is by the addition of a CH2 group. So you're adding one C to this C, so more like C plus C, we give you C2, H4 plus H2, that is 4H plus 2H, that is 6H. You see, that is the formula for ethane. Now the next member, adding by addition of CH2 group, right? 2C plus 1C is 3C. 6C plus 2C is HC. So we can use that's the succession they're talking about. Okay. Please, if you are following me, I want to see a thumbs up. Only golden. Am I in the class with only golden? I can see Lucas and Melody. So now, alkyl groups. Alkyl groups, as you can see on the screen, they are group formed from alkanes, but then they now lost one hydrogen atom, so they are short of one. Okay, so alkyl groups here lost one hydrogen, so the general formula is now this: CN H2N plus 1. So alkyl groups usually in a formula, they are usually written as substitutes some of the time. Now this is a table containing many homologous series, their general formula and their functional group. Okay. So this table is what I believe you already have. Now this alkyl now is also called aldehyde. So one is the old name, the other one is the new name, something. Then this is also called ketone, and this is carboxylic acid. Now, if you see this functional groups, what does it tell us? It tells us that when we see a structure and we see a COH, we know that this structure is coming from the aldehyde family. And so when we are naming that compound, we are going to end it with a what? Now we are talking about COH. We are going to end it with a al. This is the end name. So let's take, for instance, we have this. Okay, this is what? How do we name this? We'll name this by, first of all, how many carbon atoms do we have? We have 3. 1, 2, 3. So this will tell us it's a probe. 3 signifies probe. Now what's the functional group there? Functional group there is a what? An aldehyde. As I've written here, alkanal. Okay, how do we know that? Because of the functional group COO and COH. See the way it is written here. It's the way it is actually drawn in this structure. Okay, so this is a what? A pro. And we say when we see, we said when we see a CHO functional group, we call it a proper null. This is the end name. Now, what if we now have in this structure a double bond here? Okay, it's now going to be a propene null, because we are now identifying 2 functional groups here that can go together. The functional group of the alkanal and the functional group of alkene. Are you there? So this will now be a propene now. Now another thing is some of you tend to mistake one for the other. Okay. Now when we see this structure, oh, I'm drawing advanced structure for you people. When we see a structure like this, now these two don't belong to the same homologous series. These two structures are having different functional groups. Who can tell me what's the functional group of the structure 1 and the structure 2? Yes, I want to hear from somebody. Golden. Golden, tell us. Am I the only one in this classroom? Oh.
I cannot.
Which one? The first one is what? It's what? said. So no one, you, yes?
The first one is an
Alkanon.
afternoon.
Okay, alkanon, yes. The second one. The second one is what?
An ester.
An ester. Okay, so I can see in the chart. Winner said alkanon and Melody said ether. Now there is ether and there is ester. Okay, ether has the functional group O. So an alkyl group is here, an alkyl group is here. It's different from ester. Ester has this functional group COO. Okay, so an alkyl group is here, carbon to 2 oxygen, and then the oxygen is to the next carbon. Okay, so this first one is ether, and this is ester. Okay, so now the first number one is what we say alkaline and ester. Okay, so also learn the habit of also calling it keton, because alkaline is a whole name. Okay, so also get used to using the word keton and aldehyde for the CO group and for the CHO group. Okay. Now, sometimes we will see some structures where we would see both two functional groups, okay, in one structure. So what do we do? Now there are trends of priority. How you're going to know which functional group you are going to prioritize over the other one. Okay. Let me write it down. So that when you are naming, you will not be confused and be thinking, oh, which functional group should I use as the parent's name? Should I use alcohol or carboxylic acid? Now this is the priority order. We have carboxylic acid, I hope everyone is jotting down. Or if this is what you are very conversant with, you can tell me to skip. So I will just give you questions to attempt. Amide, amide, nitrile, aldehyde, okay, keton, alcohol, amine, alkene, alkyne, and alkane. You see, alkane is down below the series. Now, these functional group trends will help you to know what will be the suffix. That is what will be the parent carbon. Okay, so we can see that this is the top. Carboxylic acid is ruling. So let me give an example of a question. Now we can have, this is the list. I hope you have all written it. Now we can have a structure like this. C H H. Now in this structure, you can tell me the functional groups we can find in this structure. If you know it, raise up your hand. What are the functional groups that are present in this structure? Okay. Now, before, let it not seem like we are going too fast, because I'm actually assuming these are, you've been taught nomenclature, how you name organic compounds. So I don't have to go over, oh, this is the structure for ethane, for propane, for butane. Am I correct? You know those basics already. Please, if you don't, I want to see a thumbs down. If that you can't see a structure like this and you can confidently name it something like this that I'm drawing out in this other side, or if you don't know anything about functional group before now, you don't know what I'm talking about, even with this, at this point that we have reached, you are lost. Let me see your thumbs down, and then you unmute your mic and talk to me. Tell me the parts that you have no idea what is going on. There are 1, 2, 3, 4, 5. 5 persons in this class. So I'm expecting response from everybody. I'm not asking just one person. I'm asking all 5 of you. Our moving on, it depends on your response. I'm actually asking if everybody understands up to this point, if everybody is following us. If you don't know the basics, like it's only a fossa, right? So Uyi and Melo, the 4 of you understand up to this point. Is that true? Winners, answer me. I'm waiting for the 3 of you. Golden Uyi and then Melody. I've seen your response, Golden and we. Melody, we are waiting for you. So for Efosa, please unmute your mic. Efosa, I want to speak with you. Everything I want to be saying now, I want you to be answering. In fact, it's the two of us that are in this class majorly today. So everything I'm saying, I will be
Okay, ma.
asking you. Then you will be telling me. If you don't understand, you tell me to repeat. Now you
Okay,
said
ma.
you are not sure about the basics. That is naming organic
Yes,
compounds,
ma.
right? So now when we want to name
Yes, ma.
organic compounds, there are certain rules we need to follow. Chemistry has rules. When you follow those rules, you have no problem. Okay?
Okay,
Now
ma.
we have an example. First, one of the things we need to know is that carbon as an element should have 4 bonds attached to it. Once there is not up to 4 bonds attached to carbon, for these people's level now, you should know that there is a problem. Okay? That means there is no complete bonding. So we can have different structures like this. This is an example of a structure that I'm drawing now. Okay? And you might
Yes,
be
ma.
asked to name this structure. If you notice, each of the carbon has 4 bonds attached to it. How do they have 4 bonds attached to it? Let us label these carbons. We have carbon number 1, carbon number 2, 3, 4, and 5. This carbon number 1, all these lines attached to it are for carbon number 1. All the lines surrounding it. Carbon number 2, all the lines surrounding it belongs to it. So if you count all the lines surrounding carbon number 2 is 4. If you do the same thing, all the lines, which are the bonds now, bond, surrounding it is 4 for carbon number 3. The same thing for carbon number 4, the same thing. So if you have a structure that is like this now, I'm giving another example. And you see this structure. This structure is not complete though. Why? Because our carbon, this is our third carbon here, is not completely bonded. So you have not finished drawing your structure. There is a problem there. So when you want to even write the molecular formula of this, you say C3, that is 3 carbons. Then how many H? 1, 2, 3, 4, 5, 6, 7. 7, which is inaccurate. Okay, so
Mm.
that is like the basics. Now, if we want to name
Okay, ma.
this first structure here that I drew here, if we want to name it, there's what we call prefix, there's what we call suffix. Prefix is like like when we say previous, it's like before the name. Then suffix is after, at the end of it. That is why we treated homologous series, and that is why we treated functional group. When you see a carbon like this, the first rule number 1, when you see a structure, rule number 1 is count the longest carbon chain. Okay, the longest carbon chain
Yes,
here,
ma.
that is the longest continuous, not only the longest, but the longest continuous. The longest continuous can be going like this, provided it's the longest and it's the continuous. The longest continuous can be just straight. Where is my mouse? The longest continuous can be just straight. The longest continuous can just be like this. Okay? Provided it's longest continuous. I'm just exaggerating, by the way. There's no like structures will not be this roughly drawn. But at the end of the day, it should be longest continuous. So you can actually see structure that can be like this. For example, we have carbon to another carbon to another carbon to another carbon here to another carbon here. So this is actually longest continuous. So it doesn't mean,
Yes, ma'am.
it doesn't matter how it is bending and bending, provided you have not reached the end of your longest chain. Okay. Now let's go back to naming our carbon, our structure. We said the first thing is to count the longest carbon chain. In this case, it's very simple because it's a straight chain. Carbon can be straight or branched. This second
Yes,
example
ma'am.
here is branched. This first one is straight. So for this straight chain, how
Straight.
many carbons do we have? We have 1, 2, 3, 4,
Five.
5. Good. And 5 means pent in mathematics. 5 means pent. So that
Pentane.
means we have, yes, means this will be
Pentane.
pentane. Yeah, how do you know it is pentane? Because it is 5 carbon pent, and the functional group is telling us it is ane because the functional group is
And
single bonds, right? So assuming we have double bond
yes,
here,
ma'am.
this will no longer be pentane, oh, because the
Yes.
functional group
Okay.
have changed.
Pentanol.
It's now what?
Pentanol.
No, double bond functional group is not pentanol.
It's
What do
Petine.
we call?
Pentine.
Good, in. So it is pentene. But to accurately, really accurately name this, we have to write the number where that double bond is. Now we'll count the carbon to carbon bond. This is the first bond. This is bond number 1. This is bond number 2. So to properly write this, we say this is pent 2 in. The 2 in there
In.
is telling us that the double bond is in the number 2 position.
Two.
Yes. So that is it. That is how we write this kind of a structure.
Yes, ma'am.
Okay. There's something I wanted to say just now, but it just quickly skipped my mind. So this is for this first structure. What if our structure now is having a O here? This O I have added at this top is telling us what the alcohol functional group is there. So that means we are now seeing 2 functional groups there. We ignore alkane single bond functional group, okay? We are now seeing 2 functional
Yes.
groups there. We are seeing alcohol and
Yes.
now the reason why we are saying writing this pen2 in is that from this name pen2 in, we can draw back this structure. How can we do it? This was what came to my mind, so let me quickly do it. Pent there tells us it's 5 carbon, so we are writing our 5
Yes.
carbon. 1, 2, 3, 4, 5. Then 2 in tells us we are having a double bond at the second position, so we have drawn an
Yes.
accurate structure as the first one. But don't forget, so okay, let me finish. So we now have H here, H here, H here, H here, H here. So this is pent 2 in. I'm now drawing it from the name. Okay, who can tell me what is wrong with this my structure, or is nothing wrong with it?
Um, Something is wrong with it.
What is wrong with it?
Every carbon supposed to have two hydrogen. So the it's supposed to have 4 bonds.
Good.
So it's having more than 4. So one
Yes, this
hydrogen
second
is
one.
removed from.
Yes, that is it. We remove these 2 hydrogens because they are making it, they are doing another thing that is not supposed to be done for carbon. Okay, so you have really understood up to this point. So when so back to the, we have established the basics of it. Now I said we have a OH group now attached to it. So how are we going to name this? Because we are having both OH and in. We'll come back to this. That's why I introduced this priority of functional group. We say carboxylic is the topmost. So when you see carboxylic, in a functional group in any structure, you name it as the parent. Priority or functional group. Okay. So in this priority, it is going down in terms of what is really prioritized than the others. Okay. So now since we have double bond and OH group is alcohol, double bond is alkene. Now the OH, look at where OH is. It's at the top. Alkene is at the bottom. That means we will prioritize alcohol than alkene. That would mean that the parent name for this our structure will be alcohol, not alkene. So to properly name
Yes.
this, we say pent, pen2 in
Two,
3 all.
all.
Why are we saying 3 all? Because the alcohol is attached to the third carbon. These positions, this
Yes.
1, 2, 3 is very important. Okay. And because of
Yes, ma'am.
that, we'll have to be numbering in a way that will befit that pentane. Okay. Another example to explain that. So now let's take the same structure, but this time around, let's make it 7, 2, 3, 4, 5, 6, 7. Okay. And then our alcohol is here. Okay, and then our double bond is here, still in the 2 position, and the rest people are just hydrogen, 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 and the rest hydrogen. So how do we name this guy? To properly name this, the first step, we say your longest carbon chain is what? In this case, our longest carbon chain is how many? Efosa. 1.
Ma,
What is the longest carbon chain here?
from from the um
The red
from
one.
the right side. Yeah.
Yes. What's the longest carbon chain?
From the right side.
This, yes, this number 2, this second structure now
Yes.
that I wrote with red. What is the longest carbon chain?
Heptene. Hep.
Good. 1, 2, 3, 4, 5, 6, 7, which is for EP, right? We'll write it EP
Yes, ma.
first. Then what other thing are we noticing here? Are there any functional groups? Yes, there are functional groups. We have double bond again and alcohol. So what are we going to write?
Yes.
What's the position of the double bond and the alcohol? Remember, alcohol is of more priority. So you see this priority thing I wrote here, you have to memorize it. It's something you have to know. Okay.
Yes, ma.
So now EP, and then we see the OH group here, and then we see double
Hep
bond. What position are
bond.
there here? Since OH group, the alcohol is the one with more priority, when we are numbering these longest carbon chain, we should number from the side that favors alcohol. That is from the side that when we are writing our number, it will give us the smaller number. So we must not number from here. We can number from
Yeah.
this side. It mustn't be from right to left or left to right. Anywhere that gives us the smallest number in terms of the higher priority is the one that is good to go. So we will not say this should be number 1, 2, 3, 4, 5, 6, 7. If we do that, then this will now be our alcohol will be in the number 5 position. That is wrong. Instead, we'll number from here. 1, 2, 3,
1,
4.
2, 3, 4, 5, 6, 7.
Yes, that's how we would number it. Okay. If we do that, our
Yes, ma'am.
alcohol is in the number 3 position. Between 5 and 3. 3 is the smaller number. So we will number from the side that will give us that our functional group is a smaller number in position. Okay. So that is to say it is numbering from this side that will favor us. That means any other numbering, we need to number any other thing, we must start in that same side, because the highest priority functional group started from that side. So we'll continue in that lane. We will not come and say, oh, because double bond is number 2 from this side, we will now come here again and be counting from here. No. Since we've started counting from this other side, from this right side, we'll stick to that place. Okay? So from here,
Yes, ma'am.
this will be
Yes, ma'am.
ept. Okay? Ept. The double bond is in what position? This double bond, this is
6.
bond 1, 2, 3, 4, 5. Okay? The double bond is what
Ma,
we
I
are
don't understand how you
counting.
did it just now.
Okay. Let me remove the number. To know the position where the double bond is, this double bond is between carbon 5 and 6. It's not belonging to only
Yes, ma'am.
carbon 6. So we are not necessarily counting
Yes,
the
ma'am.
carbon. We are counting the bonds to know the position it is.
Yes,
Okay?
ma'am.
So double bond can either be in position in this place, this place, this place, this place, or this place, or this one. So there are four. There are 1, 2, 3, 4, 5, 6, 6 possible positions where the double bond can be. There cannot be double
Yes,
bond
ma'am.
between carbon and hydrogen, because hydrogen can only carry 1 bond. It's carbon that can carry 4
Yes, ma'am.
bonds. So that
Yes,
is
ma'am.
when we want to know the position of the double bond, we are counting the carbon to carbon bond, the bond itself, not the carbon. Okay, so this is bond 1. Since we
Yes,
started
ma'am.
counting from this side, we continue counting from that side. This is bond 1, bond 2, bond 3, bond 4, bond 5. So this is ept 5 in. Okay, our alcohol is position 3, 3 all. Do you understand the fossa?
Yes, ma'am.
The
Yes,
rest
ma'am.
of you, the rest of you, do you understand? I can see Sharon. I don't know if she is chemistry. Okay, so this is just for this. Now, what if we have substitutes in our structure? Let me draw another structure. Like, for example, we have 1, 2, 3, 4, 5, 6. Okay, this one now, to name it, is what we are to do. We said rule number 1 in naming your compound. Longest carbon chain. Don't ever skip that rule number 1. Longest and continuous. Okay. So, what's the longest carbon chain in this structure?
Hexane.
Hexane. That is 7. Okay. Hexane. Is that true? Look at it very well. Double check it. If I told you carbon can be branched or straight. Organic compound rather, not carbon. Carbon chain can be branched or
Non-name. Non-name.
non-name. No,
Because the
it's
carbon
not.
is 9.
You are counting all the carbons. You are not counting the longest continuous. With the way you are counting it, to make it 9, you count and reach the end. Then you now came back again to go down. Something like a straight chain. Then you came back again to go down again. It's also not hexane.
Octane.
How did you get octane? Explain to us.
Okay. You said the continuous longest chain. So I
Mm-hmm.
counted from this place. Then I stopped at the C. Then I
Okay.
went down. I left the other C.
Yeah. Okay, you did like this. From here, right? 1. This is continuous.
Yes, ma.
Are you seeing it? So this is the longest continuous. This one here now will now be a substitute. That's what is called substitute. That is the part of the carbon that did not join the longest continuous. It was not a part of the longest continuous. Okay, so when you have structures like this, you draw all the possible longest carbon chain, the possible continuous carbon chain. The one that is the longest is the one you go with. So it is. Oh, how would I erase this thing now? Please excuse me. So the longest continuous in this chain, I don't know why it's not going back. The longest continuous in this chain is this. So it is easy to draw your longest continuous to just be, let me use the red marker now, from here to the end like this. This is one long continuous. Nobody's arguing that, but it's not the longest. Emphasis on the longest continuous. Okay. This one that I used red marker for is a long continuous carbon chain. True, but it's not the longest, because by the time you go down, you are getting a longer chain. Okay, that one we read is giving you only 6 chain. 1, 2, 3, 4, 5, 6. Okay, so this is the longest I would have to redraw this structure because I just couldn't remove. Okay. Okay, so the longest continuous carbon chain, we have outlined it to be like this, right?
Yes, ma.
So this is now going to be octane. Oct.
Yes, ma.
Well, we should not be in the hurry to write in. What's the functional group we see here? What's the functional group in this structure?
double bond, then
Good. Double bond and
then alcohol, OH, two double bond.
no. I know what you're saying, but that's not double bond. Double double bond is for alkene. Eh? Alkene is having double bond functional group only when that double bond is between carbon and carbon. This other double bond you are seeing here is between carbon and oxygen. That's not
Yes,
alkene
ma'am.
double bond. That is not the one that is for alkene functional group. This one is giving you a different functional group. That is why it's always good to look keenly into how your functional group will form. So what functional group is giving us this?
Ma, I don't know.
Okay, who is even answering me? The rest of you.
Efosa.
Okay, Sephosa. The others, tell us what functional group is CO. CO is what functional group? When you see this kind of structure, you can recognize this CO. That's the functional group. Yes.
Acanon.
Alkanon, yes, which is keton. So now, and we say that when we see that one, when we see alkanon, we'll call it one like this, right? So we have two functional group, alkanon or keton and double bond. So now let's go back to our trend. Let's see the one that is of more priority to know who will be the parent. Look at alkanon keton is at the top here, and then alkene is at the bottom. So alkaline is of more priority. Okay, so this is now going to be alkaline. We can now say this is octane 1, but then we've not written the position of each of the in and the 1. So we will write this to be oct. We'll count from here, since this is where we give us the smallest number for the alkyl one. So this carbon number 1, carbon number 2, 3, 4, 5, 6, like that. So the 1 is in 2 position. So this is 2, 1. Then our double bond is in what position? Can you tell me, winner? No. Efosa. What position will be the alkene, the in group?
Ma,
The double bond is in what position?
number 3.
The
Number 3.
no, the double bond. This double bond here is in what position?
Number 4.
It's like you're guessing. Okay, let me remove all these many write-ups. The double bond, we are counting from this place. Want to know what position is the in this double bond? So what position is it?
Number 5. Number 5.
You're sure it's number 5?
Yes.
Because this is double bond, this is bond 1, carbon to carbon bond 1, carbon to carbon bond 2, bond 3, bond 4, then this is bond 5. So this is oct 5 in 2 1. But we are not done. We are not done. Why are we not done? Because we have not named this substitute. We've not added this substitute. We have to make sure everybody is participating in the naming. Now this is an alkyl group, ALKYL. The one that will say it has CnH2n
Ma, can you
plus
come
1
again?
formula. Okay, from where? Like where should I start to come again from? You said? Hello? I can't hear the person that said I should come again. I'm seeing in the chat, Winner said, can I show you what I just did? I wish I know which part you're talking about. Is it still this example you're talking about, Winner? Please, in case I don't see your message on time, the moment you send the message and I've not responded to it, you can unmute your mic and interrupt me.
You don't understand when you say out 5 in so something like that.
Okay, oct 5 in. Okay, this 5 in. The 5 there means the position where the double bond is. And the 2 there is the position where the alkyl 1 is, which is the functional group keton is. Okay, so now looking at this structure very well, I said when you want to know the position where the double bond is, you will count the bonds, the carbon to carbon bonds. Okay, now we have been counting from this side, from this right side, not from the left side, not from here. Why are we not counting from here? Because when we count from this other side, our functional group of priority, which is this C to double O, okay, is going to give us a smaller number. But if we count from this other side, it will give us a bigger number because we will make this first C to be 1. This will now be 2, 3, 4, 5, 6, 7. So it will now be number 7. 2 is better than 7 because we want it to be as small as possible, a smaller number as possible. So since we have started counting from this side, because of the functional group keton, we'll continue counting from this side in any counting we are doing. We don't change sides. We'll continue counting from this side in every counting that concerns this structure. So when we want to count the position where the 1 is, we'll count from this side, which is carbon 1, carbon 2. The carbon that has the functional group alkyl 1 is in number 2. That is why it is 2, 1. Now, how do we know the position of the double bond? Remember, there's another functional group here, which is double bond. How do we know the position of the double bond? We have to count the double bond, the bonds, the carbon to carbon bonds. Okay, when we count this bond, I know that this our structure is now one kind because of the many writings on it. So because of that, let me redraw this. So this is the same structure as that one. Okay, the only difference is I've not added the or the H. Okay, and then our double bond. Our double bond will be, let me see the other one. Our double bond will be here. I'm saying how we got the 5 in is that we'll count the carbon to carbon double bond. This is, we'll count the carbon to carbon bond, the position of the bond. This is bond 1. This is the second one. This is the third one, the bond between carbon to carbon. Remember, we are dealing with the longest carbon chain, and this is the longest continuous carbon chain. So we don't have to deal with this C outside and this O outside for now. 3, then 4, then 5. So the double bond is in bond number 5. So that is why this is oct 5 in. And then the carbon bond is what position? This is 1, this is 2. It's in the second, the functional group. This is the functional group. This is in the second position. That is why this is 2, 1. And you know how we got the oct. It's the longest continuous carbon chain. Now we've not named this C outside that is having 3 hydrogens. This is an alkyl group. This alkyl group is called methyl. That's the formula CH3. When you use the general formula for alkyl, CnH2n plus 1, you get the CH3. So now that's the only substitute we've not added to this whole naming. So we'll now say methyl oct 5 in 2, 1. But then we've not put the position of the methyl group. Okay, so this carbon number 1, carbon 2, carbon 3, carbon 4. So the methyl group is attached to carbon number 4. So we have 4 methyl. Oct 5 in 2, 1. Any confusion? Do you all understand? Winner. Winner, do you understand?
I
I want.
understand. I thought
Oh,
you are talking to everybody.
yes, I'm talking to everybody, but to you especially because you asked a question. Okay, I'm suspecting that the others are like some of you are here for the next class. I don't know, but you seem to be much today. Okay, so Melody, Golden, Uyi, and the rest of you that were here at the beginning, what are the questions you have so far? Ask your questions. We have 10 more minutes. I want you to spend that time asking questions. If you don't have questions, we can move on. Okay, since you don't have questions, I'll be the one to give you a task to do. Now, we know what alcohols are, right? Structures with OH group. Now, this question is asking which of these is a secondary alcohol. Now, alcohols can be categorized into primary, secondary, or tertiary. Primary alcohol are alcohols that have only one carbon group attached. Please jot this down to the carbon carrying the OH group. which is the alcohol functional group. Now, secondary alcohol is the one that has only two carbon groups attached to the carbon carrying the OH functional group. And then tertiary alcohol are alcohols that has only three carbon groups attached to the carbon carrying the OH functional group. Now, that is to say, if we have a structure like this, okay, for which one? For Okay, I actually wrote it on the screen. I hope you all can see my screen. I said primary alcohols are alcohols that
No.
you can't see my screen. Can you see it now, Melody?
No, ma.
Ah. The rest of you, can you see my screen? Because I can actually see it with my other
Yes,
device.
I can see it.
Okay. Melody, that means maybe your internet. Okay, so we said primary alcohols have only one carbon group attached to the carbon that is carrying the OH group. Melody, can you see my screen now?
Yes, ma'am.
So if we have this structure now, this is an example of a primary alcohol. Where is the carbon carrying the OH group? It is this carbon. This carbon I'm using black pencil on. Now, the carbon has four groups surrounding it by its four bonds. The first is the OH group, obviously, certainly. The other group is hydrogen. The other thing is hydrogen. And lastly, a carbon. So that is why we'll call this a primary alcohol. Either we say primary or we just write 1 degree, something like that. Okay? Because it has only one carbon group attached to the carbon. This is the carbon we are considering. Then this is the carbon group attached to it. Do you understand? Please, if you understand, let me see your response. Good. Now, this second example, this second structure I'm drawing, this is an example of a secondary alcohol. Where is the carbon carrying the functional group? This is the carbon carrying the functional group. What are the groups attached to it? To the bottom is hydrogen. To the top is the OH group, which is important. To the right is a carbon group. To the left is another carbon group. So it has two carbon groups attached to it. Two carbon groups. That will give us a secondary alcohol. How about a tertiary alcohol? This is an example of a tertiary alcohol. We have C to C to C to C to OH to C. Don't mind my structures are sometimes bent. So now this is the carbon carrying the OH group marked with black. Okay, it has one bond to the OH group, important. It has another bond. Its second bond is to one carbon. Second bond is to one carbon group. And the last bond is to another carbon group. So it has in 1, 2, 3 carbon groups attached to it, making it tertiary alcohol. So not only alcohols that have primary, secondary, and tertiary, amines do also. Amines have primary, secondary, and tertiary. Or I know amides have primary, secondary, and tertiary. And many groups like that. As you advance, you get to know about those other ones. Okay, so now in this question they said, which of the following is a secondary alcohol? These structures now, the first one is properly written as CH3, CH2, then 2 again, then OH. Okay, so this is the structure. Now let us see if this is primary, secondary, or tertiary. I hope you know how to draw this kind of structures. This CH2 in bracket 2, it means 2 CH2s. Okay, normal mathematics. So this CH, we can draw this like a full structure of this. First CH3, this is it here. Then they bond to the next one, CH2. This is the C and the 2H attached to it. Another CH2, C with 2H attached to it. Then our OH. These two structures are the same thing. Now, one of you should tell me, is this a secondary alcohol or not? If it is a secondary alcohol, okay. If it is not, tell me what alcohol it is, if it is primary or tertiary. I want to see your response.
Primary, ma.
Primary, very good. Who gave that answer?
Christine.
Wonderful. So Christine is also a science student, and this is your first class. So it is primary, right? Because it's attached to only one carbon. The carbon carrying the OH group is attached to only one other carbon. Okay. I see Winner is sending a thinking emoji. Winner, are you confused?
Mommy, I'm confused too.
Who are those confused?
Somehow.
Okay. Let me explain again. But you understand how we went from this structure here? How I drew the full structure, this one.
Yes.
Okay. Efosa says he or she understand. She, I know Efosa is a girl. Then we said that primary alcohols have only one carbon attached to the carbon carrying the OH functional group. You know, OH functional group means is what tells us this is an alcohol. So our focus is on that carbon carrying the OH. If that carbon has one more carbon attached to it, you know, carbon has 4 bonds around it. If one of the other bonds is a carbon group, that means it is primary. If 2 of the other bonds are carbon groups, it means it's a secondary. If 3 of the carbon bonds that are attached to that carbon carrying OH is carbon groups, it means it's tertiary. Okay, so 1 carbon group means primary, 2 carbon groups means secondary, 3 carbon groups means tertiary. Now, these are structured. This is the carbon carrying the OH. And these are the 4 bonds surrounding it, including the bond to the OH. One of them is to the OH, The second one is to the hydrogen. The third one, yeah, is to a carbon group, carbon. The last one is to hydrogen. So how many carbon groups is this carbon attached to? It's only one. Why is why it is primary? So A is not our answer. Do you people understand now? All right. Now let us see the B, if it is the one that will be our answer. Let me do and go. Time is already fast spent. Now for the B, we have CH3. That is 3 hydrogen attached to our C. The next one is CH, only one H attached to the C. Then a double bond. Then CH again. We are doing the BO. Then another C to H and H. Then our OH. So people, tell me, is this a secondary alcohol? Yes, I need response.
No, ma.
Very good. Christine again. Another person should tell us, why is it not secondary? Yes. Winner, you said Efosa, you said you understand now. So tell us, why is it not secondary? If it is not secondary, then what is it? Is it primary or tertiary? Yeah, Christine, tell us. I'm tired. I want to go.
It's a primary, ma.
All right. It's a primary. Why is it a primary? Because there's only one carbon attached to the carbon carrying the OH group. So let me write that. Where is my pen? Now this is the carbon carrying the OH group. One is OH, hydrogen, hydrogen, only one carbon. Only one other carbon. Now let's draw the C and D quickly. This C, CH3, CH2, three of it, CH2, CH2, another CH2, then OH. This one is the same thing. The same thing. Oh. Then the D, let us draw the D. Let me erase this ones. This C is also primary. Okay. Then for our D, we have CH3, C to 3H, C to 1H. Then our OH group, then C to 3H. So people, tell us, is this secondary or not? Melody, Winner, Efosa, Odion, Sharon, Uyi. Tell us, this structure here, is it a primary alcohol or is it a secondary alcohol or not?
Ma'am, I'm feeling like it's a secondary alcohol.
Very good. Why?
Because the whole H is connected to two carbon.
Okay, very good. You mean the carbon carrying the OH is connected to two other carbon, 1 and 2. Very good. So D is secondary. Why C? C, let us just do C, even though it's not secondary. This C, you see C bracket CH3. This means there's CH3 here, CH3 here, CH3 here. 3 CH3s, then OH. This is what? Primary, secondary, or tertiary? Anyone can give us the answer. Remember, we are considering the carbon carrying the OH group. So which one is this? Is it primary, secondary, or tertiary? Look at all the bonds, all the things it is attached to. How many carbons is it attached to? Yes, winner. Christine, Efosa, Melody.
It's attached to one carbon bond.
Are you sure, Christine? Look at the carbon carrying the OH group.
Top one.
It's
Which
not
one
the
are we?
up one. This one at the bottom, the second one. This one, we've already done this one. So which one is this one? Is it primary, secondary, or tertiary? The rest of you, I'm waiting for your response. Melody, you're not saying anything again. Christine, have you gotten it now?
Is this secondary?
Okay, that means you're not sure. And it's actually not secondary. Okay, now when we look at this carbon, this is the carbon we are considering, right? This carbon that is in red. And there are 4 bonds surrounding it. We said one of the bonds is the OH group. Okay, good. The second bond, okay. Probably is because I wrote the H before the C, which is actually not supposed to be so. Okay, does it make sense now? Kristen.
I'm still not sure.
Okay. So let me just go on like that. So now we are considering this carbon at the middle. Okay. The first bond is to the OH group, which is definitely because we're talking about alcohols. Now the next bond, bond number 2, is connected to another carbon group. Bond number 3 is connected to another carbon group. Bond number 4 is connected to another carbon group. Okay, so in essence, the carbon carrying the OH group is connected to 3 other carbon groups. And we say when the carbon carrying the OH group is connected to 3 other carbons, it is what? Primary, tertiary, or secondary?
Tertiary, ma.
Tertiary.
Tertiary. Tertiary.
Very good. Very good. Okay. Apparently today's class, you people are much. So I will be writing today, unlike the other days where I would just have Melody and Winner's names on my head. So please give me a minute to get my pen. Oh, let me just write it here. So we have I'm actually done with today's class since you all don't have questions. But don't leave, oh, if you leave. Big Faith that came last is the first to leave. We have Efosa. We have Kristen. We have Melody. Dion. Please, if you are two in your class, that is, if two persons are sharing your name, you can let me know to include your surname so I don't get confused when I'm putting in your attendance. Then winner. All right, bye-bye. I hope you all learned something today. I barely.
Ma, did you write my name?
Yes, I wrote your name. I know you are here for the name. Are you not doing you, sir?
Yes, ma. Yes, ma.
Okay, I wrote your name.
Okay, ma. Thank you, ma.
Okay, bye.